Hi, my name is Samarth, and our teammates are Darshan, Kushala, Sachin, and Srishti. So today we are going to present you a report on hospital management system about the architecture, design, and implementation report. First, let us understand the system architecture of this hospital management system. We basically have multi-tier system architecture, which includes client layer, application layers, database layers, and some external services. Client layer consists of web and mobile interfaces for patients, doctors, nurses, and administrators. Application layer basically consists of modular business logic with some of the REST APIs managing patient records, appointments, etc. Then comes the database layer, centralized ACID complement storage for patient demographics, medical histories, appointments, and uh, a huge inventory data. We also have some of the external services such as APIs, SMS or email notifications, and some secure payment gateways for enhanced functionality. Let us have the scalability and future ready design. So the key benefits of this architecture is it has horizontal scalings, modular independence, high speed access, clear separations. Cloud deployments enable seamless capacity expansions during peak loads for horizontal scalings, whereas the APIs allows the module replacement without system-wide disruptions. Similarly, a centralized database with intelligent indexing ensures rapid data retrieval. And for the clear separation, isolated UI, logic, and data layers enhance the debugging and maintenance. The architecture supports future expansions, including OPD managements, laboratory integrations, and telemedicine capabilities. The next slide will be explained by my teammates.
Now I am going to explain the system modeling framework. First one, use case model. Show how the different users, patients, doctor, admins, pharmacy staff interact with the system. Like example, booking appointments, generating reports, dispensing the medicines, etc. Next one, class model. Shows the main entities in the system like person, patient, doctor, admin, with inheritance relationship and association for the compressive data structure. Next one, sequence model. Sequence model that illustrate the message flow for the appointment, booking, bill generation, and medical record updates, ensuring a proper execution order. Then next one, activity model shows the workflow process like maps workflows from the patient registration to the consultation, billing, insurance, processing, and medicine dispensing with a decision points. Now I am going to explain the core class relationship. This section explains the main classes and how they relate inside the system. First one, person class. Base class that stores the basic information like ID, name, email, and contact, used as a parent class for the other roles. Next one, patient class. Inherits from person, contains the patient's specific details like admin's date, diagnosis, and the treatment details. Next one, doctor class. Includes a specialization, schedule, and a doctor-patient relationship. One doctor can attend a many patient. Like next one, admin class. Manages the system operation, backups, logs, and has control over the doctors and patient. A diagram on the right that explains the shows the simplified visual representation of the hospital system components and demonstrate how the department process and roles are connected, helps to visual understand the overall system structure. This slide shows the modeling framework used to design the hospital management system. It starts with the four models. The use case model that explains the user interaction, the class model that defines all main entities, the sequence model showing message flow, and the activity model representing the work processes. The bottom portion explain the core classes, person, patient, doctor, and admin, and how they inherit interact with other uh, patient. Next slide will be explained by team members.
Hello everyone, I am Srishti Mandre. Today I am going to explain about modular function distribution. First is the patient model. It handles the patient registration and login, manages authentication and secure profile updates, allows patients to book appointments, and stores all patient data securely. Next is doctor model, allows doctors to manage their schedules, provides access to patient medical history, enables doctor to update diagnosis and treatment notes. It also supports generating electronic prescriptions. Next is the appointment model, manages the complete appointment booking process, checks for schedule conflicts and avoid double booking. It sends automated reminders, all notifications, allows modifying or cancelling appointments smoothly. Fourth one is the billing and insurance model. It automates the bill generation for treatments, calculates charges accurately, and integrates with insurance providers for claims. It also creates invoices and tracks payment status. Next is the pharmacy module. It manages medicine stock and availability, validates prescriptions before dispensing, tracks expiry dates and stock levels, and it also sends alerts when medicines needs restocking. Last one is the admin model. It is used by administrators to manage users and roles. It monitors overall system activities, generates reports for analysis, and it maintains audit logs for security and compliance. Next slide is design objectives and principles. Core design objectives are scalability, security, reusability, performance. Scalability supports many users at the same time. It ensures smooth performance during peak hours, and security uses encryption and security access control. It protects sensitive medical records. In reusability, modular design allows easy reuse of components. Modules can be upgraded without affecting others. Performance uses optimized database queries, implements caching and load balancing for fast response. The design practice, object-oriented design. It uses OOPS concepts like classes, inheritance, and encapsulation. Next is modular architecture. Each module works independently. Issues can be fixed without affecting other modules. Separation of concerns. UI, business logic, and database are kept separate. It improves maintainability. Next is loose coupling. Modules communicate via REST APIs, make the system easier to upgrade and integrate. Next is secure coding. It follows input validation, encryption, and session protection and prevents security attacks. Last is the API first approach. APIs are designed best for UI or database, allows easy integration with labs, insurance systems, and partners. Next slide will be explained by my team member.
Hello everyone, I am Sachin Jadhav. Now I will be explaining technology stack. First we will know about front-end development. Here we have used React, Angular, HTML, CSS and JavaScript to create a smooth and responsive user interface. And for backend services, we have used Django, Node.js and Spring Boot handle to all the server-side logic and securely and efficiently. For the database system, we have used MySQL and PostgreSQL, which stores all the hospital data readable with strong consistency. And the development tools are GitHub, Selenium, Postman, JUnit, and PyTest, which help in code management and automated testing. And the hardware requirements which we have used are the system works best on a cloud server with an 8-core CPU and 16 GB RAM. Next slide, Ahmed. And the second slide is testing strategy. Here we have used unit testing, which tests each module individually to ensure basic functions work correctly. And the API testing is verifies communication and data transfer between the different system modules. And integration testing, which checks how combined modules work together in the system. And the system testing ensures the entire system workflow functions and correctly from start to finish. And the performance testing is used to measure system speed and stability under heavy usage. And for security testing, it is used to identify and fix the vulnerabilities to protect sensitive data. UAT, which allows real users to confirm that the system meets their needs. And lastly, we have used simple test cases, which includes checks for login, appointment booking, records updates, and prescription creation. And the next slides will be explained by Darshan.
Conclusion and deployment readiness. The hospital management system design the component address architecture, system modeling, model function distribution, implementation strategy, and regression testing protocol. High performance modular designing scalability, enterprise security, high performance optimized for the speed with the intelligent catching and the load distribution. Model designing. Independent component enable flexible upgrade and the maintenance. Scalability. Cold ready to architecture supporting and growth expectation. In enterprise security, multi-layer protection, self-grading, sensitive presentation data. The system is fully prepared for the development, intelligent and the deployment for the in real hospital environment, offering a robot function for the digital healthcare transition.